China's metal storm weapon, a historical present and future perspective. Introduction. In the landscape of modern warfare, technological advancements are pivotal in shaping military capabilities. Among these innovations, China's metal storm weapon stands out as a potentially revolutionary military tool. This report delves into the historical context, current developments, and future implications of this groundbreaking technology, which promises to redefine the parameters of aerial defense and ground combat. Historical context. The concept of the metal storm was first introduced by Australian inventor Mike O'Dwyer in the 1990s. His company Metal Storm Incorporated showcased the potential of electronic firing systems, achieving astonishing rates of fire with a prototype that included 36 barrels capable of reaching up to 1 million rounds per minute. This innovative approach aimed to enhance the efficiency and effectiveness of military engagements, particularly in countering aerial threats. In 2006, O'Dwyer's technology attracted the attention of the Chinese People's Liberation Army (PLA), which expressed interest in acquiring the technology. However, due to various technical challenges and strategic considerations, the collaboration did not materialize, leading to the eventual bankruptcy of Metal Storm Incorporated in 2012. Despite this setback, the foundational concepts of the Metal Storm technology laid the groundwork for continued research and development, particularly in China. Current developments. As of January 2025, Chinese scientists have made significant strides in developing the metal storm weapon. This sophisticated machine gun consists of 5 or more barrels, each capable of firing at an astonishing rate of 450,000 rounds per minute. This results in an unprecedented density of firepower, positioning it as a formidable countermeasure against hypersonic missiles, which travel at speeds exceeding Mach 7. One of the most significant challenges in developing such a weapon is the logistics of ammunition supply. Traditional machine guns rely on mechanical systems that cannot sustain the demands of a weapon capable of expending millions of rounds per minute. To address this, researchers in Taiyuan, China have devised an innovative solution: a container-like replaceable magazine filled with disposable barrels loaded with ammunition. After firing, the entire unit can be discarded, streamlining the reloading process and significantly enhancing the weapon's operational efficiency. The project, spearheaded by Lu Shutao from the North University of China, employs a novel electronic trigger system. This trigger utilizes coils to produce a high-energy metal jet that ignites the explosive, achieving a firing time of just 17.5 microseconds. This rapid firing capability is essential for meeting the PLA's requirement for a staggering 7,500 shots per second, demonstrating the advanced engineering and technological prowess behind this project. Technical specifications and capabilities. The metal storm weapon's unique design and firing technology offers several tactical advantages. 1. High rate of fire. With the ability to fire 450,000 rounds per minute per barrel, the weapon can deliver a continuous barrage of fire that is significantly higher than the firing rates of existing defense systems such as the U.S. Navy's Phalanx system, which has a maximum rate of 4,500 rounds per minute. 2. Intercepting hypersonic missiles. The sheer volume of fire generated by the metal storm weapon provides a viable means of intercepting hypersonic threats, which present unique challenges to traditional missile defense systems due to their speed and agility. 3. Disposable barrels. The use of containerized disposable barrels addresses the logistical challenges of rapid reloading, allowing for sustained operations without the need for complex ammunition supply chains during critical engagements. 4. Electronic triggering mechanism. The advanced electronic trigger system enhances firing precision and response time, making it suitable for high-stakes scenarios where rapid engagement is crucial. Strategic implications for modern warfare. The introduction of the metal storm weapon has far-reaching implications for modern military strategy. As hypersonic missiles continue to evolve, traditional missile defense systems face substantial limitations. The metal storm weapon offers a complementary approach to missile defense that prioritizes rapid response and high-volume fire. 1. Point defense capability. While the effective range of the weapon is limited to 5 to 9 kilometers, it is particularly suited for point defense scenarios, protecting critical assets such as naval vessels and military installations from incoming threats. 2. Countering aerial threats. The speed and volume of fire enable the metal storm to engage rapidly approaching aerial threats, increasing the likelihood of successful interceptions compared to traditional systems that require more time for detection and engagement. 3. Potential for saturation attacks. As adversaries develop saturation attacks using hypersonic missiles, the need for high-capacity defensive systems becomes paramount. The metal storm weapon could serve as a frontline defense in such scenarios. Challenges and limitations. Despite its promising capabilities, the metal storm weapon also faces several challenges. 1. Range limitations. The weapon's operational range may restrict its effectiveness in broader combat scenarios, necessitating integration with other defensive systems to cover larger areas. 2. Vulnerability to countermeasures. As with any weapon system, adversaries may develop countermeasures to mitigate the effectiveness of the metal storm, including decoys or electronic warfare tactics. 3. Cost and production feasibility. The manufacturing and logistical costs associated with producing disposable barrels and the overall system remain to be fully assessed. Future prospects. Looking ahead, the metal storm weapon may play a pivotal role in shaping the future of military engagements. As global tensions rise and nations continue to invest in advanced military technologies, the need for effective aerial defense systems will only grow. The metal storm weapon exemplifies the potential for innovation in addressing contemporary security challenges. 1. Integration into broader defense strategies. The weapon could be integrated with existing missile defense networks, providing a layered defense strategy that combines various technologies to enhance overall effectiveness. 2. Continued research and development. Ongoing investments in research and development will likely lead to improvements in the weapon's range, accuracy, and operational capabilities, further solidifying its role in modern warfare. 3. International military dynamics. The emergence of the metal storm weapon may influence global military balances, prompting other nations to accelerate their own advancements in similar technologies or to enhance existing systems. Conclusion. China's metal storm weapon represents a significant leap forward in military technology, with the potential to revolutionize how nations approach aerial defense. While it faces challenges and limitations, its unique capabilities position it as a critical asset in future conflicts. As technological advancements continue to unfold, the implications of such weapons will resonate throughout the landscape of global military strategy, influencing how nations prepare for and respond to emerging threats. The development of China's metal storm weapon presents several counterintuitive aspects that challenge conventional understandings of military technology and effectiveness in modern warfare. 1. Rate of fire versus effectiveness. While the firing rate of 450,000 rounds per minute is staggering and seems to suggest overwhelming firepower, it raises questions about the actual effectiveness of such a system in combat scenarios. The sheer volume of projectiles might not guarantee successful interceptions of hypersonic missiles, which could still reach their targets despite being hit by multiple rounds given their high velocity and kinetic energy. This counters the intuitive notion that more firepower directly translates to improved defensive capabilities. 2. Disposable technology. The innovation of disposable barrels and magazines for rapid fire presents a paradox. While it optimizes the reloading process and addresses the logistical challenge of providing ammunition for high rates of fire, it also implies a significant increase in waste and material consumption. In an era where sustainability and resource management are becoming increasingly important, the environmental impact and logistical burden of disposing of potentially millions of barrels raise concerns that conflict with the immediate tactical advantages. 3. Short-range limitation. Although the weapon is designed to intercept hypersonic missiles effectively, its operational range of just 5 to 9 kilometers limits its application to point defense scenarios. This contrasts with traditional missile defense systems that can engage targets at much greater distances, challenging the expectation that higher fire rates would inherently result in broader operational flexibility and effectiveness. For technological complexity, the reliance on an electronic trigger and advanced materials signifies a level of technological sophistication that may not easily translate into battlefield readiness. The assumption that higher technology equates to superior performance overlooks potential issues such as malfunctions, vulnerabilities to electronic warfare, and the challenges of integrating such systems into existing military frameworks. 5. Missile defense dynamics. The metal storm's advantages in reaction time compared to traditional missile defense systems imply that it could be a game changer. However, the effectiveness of gun-based systems against hypersonic threats must be contextualized within the broader complexities of missile defense. The idea that a rapid-fire gun could replace or significantly enhance existing missile defense strategies may overlook the multifaceted challenges posed by hypersonic missiles, including their maneuverability and low-altitude flight paths that complicate detection and engagement. 6. Cost versus capability. The high costs associated with developing and deploying advanced systems like Metal Storm could lead to a skewed investment strategy that prioritizes cutting-edge technologies over more proven, cost-effective solutions. This could create a scenario where military budgets are allocated towards high-tech systems that may not provide a proportional increase in operational effectiveness, challenging the intuitive belief that advanced technology always leads to better defense outcomes. 7. Countermeasures and adaptation. As military technologies evolve, so do countermeasures. The assumption that a new weapon will remain effective in the face of evolving threats may be overly optimistic. The Metal Storm's design could prompt adversaries to develop countermeasures specifically targeting its operational principles, challenging the notion of technological superiority as a permanent advantage. 8. Multi-domain operations. The concept of multi-domain operations (MDO) highlights the need for integrated military strategies across various platforms and environments. The focus on a singular weapon system like Metal Storm may divert attention from the broader strategic needs of coordinated military action, suggesting that a reliance on cutting-edge technologies might undermine comprehensive defense strategies. In conclusion, while China's Metal Storm weapon illustrates significant advancements in military technology, it embodies a range of counterintuitive dynamics that complicate the narrative of straightforward technological superiority and effectiveness in modern warfare. These aspects underscore the complexities inherent in military innovation and the necessity for a nuanced understanding of how such technologies will perform in real-world scenarios. The report on China's Metal Storm weapon highlights a number of significant advancements and implications in military technology that may be overlooked by many readers. Here are some key points and their significance. 1. Firing rate and mechanism. The weapon's ability to fire at a staggering rate of 450,000 rounds per minute per barrel is unprecedented. Traditional machine guns and even current missile defense systems like the U.S. Navy's Phalanx operate at a fraction of this rate. This dramatic increase in firing speed allows for a more effective response to incoming threats, particularly hypersonic missiles which travel at speeds exceeding Mach 5. This capability fundamentally changes the dynamics of aerial defense by allowing for immediate continuous fire against fast-moving targets, potentially altering strategic military calculations. 2. Innovative ammunition supply. The use of disposable barrels filled with ammunition represents a significant logistical innovation. Traditional ammunition resupply methods are inadequate for a weapon that consumes millions of rounds per minute. By discarding entire barrels post-firing, the design mitigates the challenges associated with rapid reloading, which is crucial for maintaining sustained fire during combat. This innovation could redefine battlefield tactics, allowing for prolonged engagements without the typical downtime associated with ammunition resupply. 3. Electronic triggering system. The development of an electronic trigger that operates in microseconds rather than milliseconds marks a shift in weapon technology. This system not only enhances firing speed but also improves accuracy and responsiveness in combat scenarios. The significance of this technology lies in its potential to integrate with automated systems and advanced targeting algorithms, leading to a new era of precision weaponry. For historical context and technological evolution, the roots of the metal storm concept trace back to Australian inventor Mike O'Dwyer in the 1990s, who initially faced numerous technical challenges leading to the bankruptcy of his company. China's sustained investment in overcoming these hurdles underscores a broader trend in military technology development, where nations seek to capitalize on previous innovations while adapting and improving them for modern warfare. This historical context is crucial for understanding the evolution of military capabilities and the competitive landscape of global defense technologies. 5. Strategic implications for missile defense. The weapon's design serves as a direct challenge to existing missile defense systems, which struggle to intercept hypersonic threats due to their speed and maneuverability. The metal storm could provide a complementary defense mechanism, particularly in point defense scenarios where protecting specific assets is critical. This capability may force a re-evaluation of missile defense strategies worldwide, especially among nations that rely heavily on traditional interceptors. 6. Limitations in tactical scope. Despite its impressive specifications, the weapon's effective range of only 5 to 9 kilometers is a significant limitation. This range confines its use to close-in defense scenarios, which may not be suitable for all operational contexts. Understanding these limitations is crucial for military planners, who must consider how to integrate such systems into broader defense strategies without over-reliance on a single type of weapon. 7. Broader military technology trends. The development of the metal storm weapon is indicative of a larger trend in military technology focusing on rapid-fire systems and directed energy weapons. This evolution suggests a shift away from traditional missile defense systems toward more innovative solutions that can address the emerging threats posed by hypersonic weapons. Recognizing this trend is essential for stakeholders in defense policy and military strategy. 8. Potential for future warfare. The implications of the metal storm extend beyond immediate defense capabilities. As military technologies continue to evolve, systems like this may play a crucial role in future conflicts, influencing how wars are fought and how nations prepare for engagement. Understanding these potential shifts can help analysts and planners anticipate future military needs and technological developments. In summary, while the report emphasizes the impressive specifications and capabilities of China's metal storm weapon, the underlying implications for military strategy, technology evolution, and global defense dynamics are equally important. These advancements could redefine engagement tactics, necessitate new defense strategies, and challenge existing military paradigms, making them critical considerations for policymakers and defense analysts alike. 1. Technological innovation and design. The development of China's metal storm weapon showcases a significant leap in military technology, particularly in its design and operational capabilities. This weapon system, characterized by its multiple barrels and an extraordinary firing rate of 450,000 rounds per minute per barrel, represents a radical departure from traditional machine guns. The innovative use of a replaceable magazine filled with disposable barrels addresses the logistical challenge of ammunition supply for such a high-consumption weapon. The introduction of an electronic trigger mechanism further enhances the firing efficiency, enabling rapid response times that could surpass existing missile defense systems. This technological evolution not only highlights China's commitment to advancing its military capabilities but also raises questions about the future of conventional warfare. 2. Strategic implications for missile defense. The metal storm weapon's capability to intercept hypersonic missiles traveling at speeds exceeding Mach 7 positions it as a formidable tool in modern defense strategies. Traditional missile defense systems often lag behind in reaction time and face significant challenges in intercepting high-speed, maneuverable threats. The rapid firing rate and the ability to engage targets almost instantaneously suggest that gun-based defenses could complement or even replace some aspects of missile defense systems, especially in point defense scenarios. This shift could alter the dynamics of future conflicts, as nations may need to reconsider their defense strategies against increasingly sophisticated missile technologies. 3. Historical context and evolution of military technology. The origins of the metal storm concept proposed by Australian inventor Mike O'Dwyer in the 1990s provide a fascinating historical backdrop to its current development in China. The initial project, which faced numerous technical challenges and ultimately led to the bankruptcy of Metal Storm Inc., illustrates the complexities involved in pioneering such advanced military technology. China's continued investment in refining and advancing this concept demonstrates a strategic focus on overcoming past hurdles and establishing a technological edge over Western prototypes. This historical trajectory not only reflects the evolution of military technology but also underscores the geopolitical implications of such advancements in a rapidly changing global security landscape. For operational limitations and future challenges, while the metal storm weapon presents a revolutionary approach to defense, it is not without its limitations. The effective range of 5 to 9 kilometers restricts its use to specific scenarios, making it less versatile compared to missile defense systems capable of engaging threats at greater distances. Additionally, the reliance on kinetic engagements raises concerns about the weapon's ability to completely neutralize hypersonic missiles, which can still cause significant damage even after sustaining multiple hits. As military technology continues to evolve, addressing these operational limitations will be critical. Future developments may need to focus on integrating metal storm capabilities with other defense systems to create a more comprehensive and effective defense strategy against emerging threats. 1. The Gatling gun. 1861, invented by Richard Gatling during the American Civil War, the Gatling gun was one of the first successful machine guns and revolutionized the battlefield. It utilized multiple rotating barrels and a hand-cranked mechanism to achieve a high rate of fire, initially firing around 200 rounds per minute. The invention aimed to reduce the number of soldiers needed in battle, allowing for more efficient use of firepower. Its design laid the groundwork for modern automatic weaponry, demonstrating how advancements in firearm technology could dramatically impact military strategy and tactics. 2. The Maxim gun. 1884. Developed by Hiram Maxim, the Maxim gun was the first fully automatic machine gun, firing up to 600 rounds per minute. It used the recoil energy of the fired bullet to eject the spent cartridge and chamber a new round, automating the firing process. This weapon had a profound effect on warfare, particularly during colonial conflicts and World War I, where its devastating firepower led to significant casualties and changed the dynamics of troop engagements. The Maxim gun exemplified the transition to modern warfare, where machine guns began to dominate the battlefield. 3. The AK-47. 1949. Designed by Mikhail Kalashnikov, the AK-47 Automat Kalashnikova 1947 is one of the most widely recognized and used assault rifles in history. It features a gas-operated rotating bolt mechanism, allowing for a high rate of fire of around 600 rounds per minute. Its reliability, ease of use, and relatively low production costs made it a favored weapon for both state and non-state actors globally. The AK-47 played a pivotal role in numerous conflicts during the Cold War and has become a symbol of revolutionary movements worldwide. Its design principles continue to influence firearms development, demonstrating the lasting impact of innovative military technology. China's metal storm weapon, a groundbreaking development in military technology, is projected to significantly alter the landscape of modern warfare. This advanced machine gun, capable of firing at rates of 450,000 rounds per minute per barrel, represents a leap forward in defense capabilities, particularly against hypersonic missiles traveling at speeds exceeding Mach 7. The implications of this technology extend beyond mere firepower, influencing strategic military doctrines and global security dynamics. Predictions for the future. 1. Revolutionizing missile defense. as hypersonic missiles become increasingly prevalent. Traditional missile defense systems face substantial challenges in intercepting these fast-moving threats. The metal storm's unprecedented firing rate may offer a viable solution, allowing for rapid response to incoming attacks. This weapon could redefine point defense strategies, making it a critical asset for nations seeking to enhance their airspace security. 2. Shift in military strategy. The advent of such high-capacity weaponry will likely prompt a re-evaluation of military strategies worldwide. Countries may prioritize investments in similar technologies to counterbalance the capabilities presented by China. This arms race could lead to a cycle of escalation as nations strive to develop faster, more efficient weapons systems. 3. Increased demand for automation and AI. The operational demands of the metal storm will necessitate advancements in automation and artificial intelligence. As the speed and complexity of warfare increase, military forces will likely integrate AI systems for target acquisition, threat assessment, and real-time decision-making. This could lead to the development of fully automated defense systems capable of operating independently in high-stress environments. 4. Challenges of ammunition supply. While the metal storm presents a solution to rapid firing rates, the logistical challenges of supplying millions of rounds will remain significant. Future developments may focus on advanced ammunition technologies, including smart munitions capable of guided targeting, reducing the need for sheer volume and enhancing overall effectiveness. 5. International arms control discussions. The emergence of such powerful weapon systems may reignite discussions around arms control and international treaties aimed at regulating advanced military technologies. Nations may seek to establish frameworks that prevent the proliferation of excessively destructive weapons, especially those that could escalate conflicts rapidly. 6. Focus on countermeasures. As countries adopt weapons like the metal storm, adversaries will inevitably develop countermeasures to mitigate its effectiveness. This could include stealth technologies, electronic warfare tactics, or improved missile trajectories that evade interception. The dynamic between offense and defense will remain a central theme in future military confrontations. 7. Tactical applications in urban warfare. The metal storm's capabilities may find applications in urban combat scenarios where rapid suppression of enemy fire and quick reaction times are crucial. Military planners could incorporate such weapons into close-quarter battle strategies, enhancing the effectiveness of ground forces in densely populated areas. 8. Potential for misuse and escalation. The availability of advanced weaponry increases the risk of misuse in lower-intensity conflicts or by non-state actors. The potential for these systems to be employed in aggressive posturing or preemptive strikes could lead to unintended escalations, destabilizing regions already fraught with tension. 9. Influence on global military alliances. The development of the metal storm could reshape alliances and partnerships based on shared technological capabilities. Countries might seek alliances with nations that possess advanced military technologies, leading to new geopolitical alignments and strategic partnerships. 10. Long-term impact on defense budgets. As nations prioritize funding for advanced weapon systems like the metal storm, defense budgets may shift significantly. This could result in increased military spending globally, with implications for domestic spending on social programs and infrastructure, potentially leading to societal tensions. Conclusion. The future of warfare is poised for transformation with innovations like China's metal storm weapon. This technology not only enhances defensive capabilities against emerging threats but also raises critical questions about military strategy, international relations, and the ethical implications of advanced weaponry. As countries respond to this new reality, the global military landscape will undoubtedly evolve, characterized by rapid advancements, strategic recalibrations, and an ongoing arms race. The balance between security and stability will hinge on how nations manage these developments and navigate the complexities of modern warfare in the years to come.